Okay, in this video we're going to continue our discussions of multi-threading in C#. In a previous video entitled C# Threads, we discussed adding a second thread into the application, and the reason was we were doing some CPU intensive image processing, and we wanted to free up the main user interface so that we could still access the interface while the CPU is busy doing these image processing. So we set up one additional thread. Now in this video, we're going to talk about using what it was called a task parallel library. It was introduced in .NET 4.0, and it makes parallel processing, multi-threading, much easier. Specifically, we're going to use the Parallel.For, and that is basically a for loop, like any other for loop. But the .NET behind the scenes allows you to do a for loop in multiple threads. It will set up behind the scenes multiple threads to do those iterations in the for loop, and you don't have to worry about it. You just set up the Parallel.For like any other for, and it does it for you. So we're going to apply that to the image processing similar to we did in our previous videos, and show how you can break that CPU intensive task of processing a big image into little pieces and apply a thread to each of those little pieces or tiles of the image, and see if you can speed up the image processing significantly. So what I'll do is I'll show you, I'll run the application that we developed in the previous videos. And here is the basic application. We've added some stuff for this video, but basically it allows you to open an image, and we're going to open a bitmap, and it will populate these two picture boxes. And I've got two buttons here, one called set pixel and one called lock bits. And these are two methods that were introduced in previous videos, but they both do about the same, they give the same result, but they do it differently. They have two methodologies for doing it. Set pixel basically goes through each pixel in this image, and there's about 2.3 million pixels. And it takes each pixel, reads the red, green, and blue values, R, G, and B, and sets the blue at 0, and modifies that image to have no blue in any of the pixels. So it just gets the value of red, green, blue, sets the blue to 0, and then overwrites that pixel red, green, and blue to the new value without the blue. So I'll show you the difference in these two methods. Set pixel, I'll click on it. You wait, you wait, you wait, you wait, you wait, and finally, after about 3 seconds, you come up with the modified image. Again, it's a very CPU intensive task. It goes for each pixel, gets the value, changes it, and sets it, and now you've got this modified image. Now let's do that again using the lock bits method. I'll click, and you can see almost instantly it has been modified. So you can look at the previous videos on image processing and lock bits to see what makes the difference. But in this video, we're going to introduce a third method, and that is basically to break this image down into 8 separate tiles. And I'll click on this button to show you the tiles. Let me redo this image, refresh it, and basically I've got two methods that I'm introducing here. One is to break this large image into 8 tiles, and the second is to actually process these 8 tiles to modify it and remove the blue just like I did before. And in this video we're going to see what the difference is between the 3 seconds here and doing it using parallel processing. So what I will do here is I will do a Parallel.For that effectively assigns a separate thread to process each of these tiles in parallel. So concurrently it will process all 8 of these, and you would think that maybe if I'm taking 3 seconds to do this image using this slow set pixel method, that the result here with the parallel processing of 8 CPUs would be 1/8 the time. So let's check, let's click on parallel, and you can see it's about 1 second. So Here it's maybe 3 seconds, here it's about 1 second. So it is a lot faster. It's maybe 1/3 the time, but it's not the 1/8 the time that you might expect. So again, we're going to introduce two methods to this application. One breaks it up into tiles, the other does a parallel processing on each tile. So to do that, I briefly want to go through and discuss how we might do that before we jump into any code, so we can kind of logic it through and see how we would do it. And once we do the coding, you can see, yeah, that makes sense, and you can better understand what the code is. So we've got this image, again, 2.3 million pixels. I've got 8 cores on my CPU. I'd like to break it up into 8 and do 1 core per tile. So let's kind of go through the thinking process and how we would do that. So I've got my image, and if I want to break it up into 8 tiles, there's a few things I need to do. First of all, we're going to need to break this source image up into 8 tiles. So we're going to need to define a tile area that we will break this image up into. And once we have defined that, then we can copy that data into another bitmap that's going to be about the same size, right? So the first thing we need to do is define a source rectangle. And a rectangle is basically a .NET structure that allows you to define a rectangular area located at this top left corner. So the coordinates are 0, 0 in this case, and it's got a specified width and height. So that's all a rectangle is. It allows you to find a location and a width and a height. So once we've defined that, now we know what we're going to copy into a separate bitmap to be one of our tiles. Now the next thing is, of course, we have to define that bitmap that's our first tile in the array of 8. So I define a bitmap destination, and it's basically now it's just going to be a blank bitmap, and it will be our destination. Now the next thing we want to do is we're going to be copying the pixels from here, the source, to the destination. Now it's much easier if you do that by defining a graphics object in that destination bitmap. So we will do that, and it will allow us, inside this graphics object, there is a method that allows you to specify a source and destination that you want to copy from and copy to. So we will define the graphics object. I'm going to call it canvas, because really we're kind of drawing the source bitmaps on this canvas. So we've got the source specified, the destination bitmap, and also a graphics object on the destination. Now, one thing about this destination canvas or graphics object is you can specify where on that bitmap you want to draw these source pixels. You don't have to draw it on this entire bitmap. You can make this destination rectangle to be a little small thing here in the corner and draw all of those onto this destination. In our case, we're going to have a destination rectangle the same size as the bitmap. So at this point, we've defined everything we need in order for the copy method to copy from the source to the destination. So now we just do the copy. Okay, so that kind of makes sense. You got a source, a destination, and you just do a copy. And then we iterate through again, and you move the rectangle over to the new position, over with the upper left-hand corner here, and you define the same width and same height, and here's our new source for our new bitmap. We define a second bitmap in the array. We define a graphics object on that. We define what rectangle to define where we want to put those pixels, and then we copy. So you just do that 6 more times, and you basically have copied all of the data on the source into separate tiles, and those will form an array of bitmaps. And here I've got a 4x2 array. You don't need to do that. You could have a single dimensional array of 8 elements, but I've got 4x2. Basically 8 bitmaps, and each is going to include a portion of the source image. So now that we know how we can do this, We can jump into the code. First, I want to show you the application I'm using. We've developed in previous videos. It's a fairly simple application. It's got three main components. Form 1, which is the main user interface. It's got the buttons and the picture boxes. A second class called File Operations, where you open up a file requester, you select the file you want to bring in, and it brings it in as a bitmap. Now, Image Manipulation class is the real worker here, and we're going to pass it a bitmap, and here it will go through and do that manipulation of each image, and it's going to have separate methods to do that. And we showed in the other videos, we've got a get and set pixel method, we've got a lock bits method, and in this video we're going to add two more methods, like I said, one to break out the tiles and then one to manipulate those tiles in separate threads. So now that we know how this is laid out, let's go into our application and we'll look at the main user interface, the Form 1 class. And most of this stuff existed in the previous videos. I'm only going to introduce two event handlers, and I've got two additional buttons. So down here we've got this tiles button, which is new, and a parallel button, which is new. And this, like we said, it just, I'll run it one more time, pick an image. So I take the image, this tiles button will go through, break out the tiles and put it in the picture boxes. And then this parallel method, I will call it, and it will do the image manipulation and pass it back to this user interface. So really, I'm just introducing these two event handlers. The first one, which makes tiles, we'll just call a new make tiles method that we will show in this image manipulation class, and it will pass the new file that we brought in from the open file dialog. It will break it up into an array of images, and it will return this image array, which is the 4x2 image of tiles. Once it has those 8 tiles, it will populate the picture boxes with each tile. So here's array element 0, 0, go into this picture box, 0, 1 into that, and so on. So the event handler for this make tiles button is fairly simple. Just call the method, return the array, and put that in the picture boxes. And the next one is where I do the image processing on multi-processing and parallel processing. I will take that array of 8 elements, pass it to this method. It will go through, modify the array, modify those images to take out the blue, and return as mod image array. And that's another array of 8 elements. And then I will take those elements and put them in the picture boxes to show the yellowy images without the blue. So in the main user interface application, not much change, just 2 event handlers. Now we'll go into the image manipulation class where it does the work, and I've got these 2 new methods that we just talked about. One takes in the bitmap, the source bitmap, makes the tiles, basically generates the array, and returns it as a bitmap array. The second method, parallel image process, takes that bitmap array that we just generated and modifies it to take out all the blues and returns it as a modified image array. Okay, so pretty straightforward. We're just adding 2 methods. You don't really need to understand what's going on in the rest of the application, because these 2 methods, you can reuse those anywhere. They're just taking a bitmap and returning an array. So let's look at how we make tiles out of that source image. I'm passing in a bitmap. In this case, I'm using an object and casting it to a bitmap, but you can just take in a bitmap directly. And notice I'm returning the bitmap array of tiles. Okay, pretty straightforward. Now, here I am defining a size, which is a structure. Basically, makes it a little bit easier for us. It defines a height and a width. And makes it a little bit easier to use this structure. So I'm defining a new size, and I'm setting it up to be 1/4 the width of the source image and 1/2 the height. Okay, that's the size of a tile. I've got 8 tiles, each will be this size. The next thing I'm doing is I am going to set up the bitmap array, the blank bitmap array, and that array will have each of the tiles in the 4x2 array, okay? Okay, so now how do I break the original bitmap into these 8 tiles? Well, I've got 2 for loops that will step through the image 8 times, 4 across the top and 2 up and down. So here's my 8 elements that I will be defining. Now the first thing we need to do is we need to define a source rectangle that will be the source of the portion of the image that we're going to copy over to the destination. So here's the definition of that rectangle, and I'm calling it moving tile frames because as we iterate through each iteration, this tile frame is going to start here, then we're going to move it over here, and so on. So we're kind of stepping through with each iteration to specify a new source for the copy. So that will be a new rectangle, which is a structure again. And the only thing you need to define with this rectangle is the coordinates of the rectangle, the upper left-hand corner, and then the width and height. Okay, so it will start out with the coordinates of 0, 0. Up here in the upper left-hand corner, this first rectangle will be here at 0, 0, and it will have the width and height of the tile size that we defined up above. So we're all done defining the rectangle, which tells you what the source of the image copy will be. Now, the next thing we need to do is define the 8 destination bitmaps in the array, the 4x2 array. And that's all we're doing here. As we cycle through the iterations, each element will be a new bitmap, and the dimensions will be the width and height of that tile size, okay? So we are now defined this destination bitmap, and that's the size. So now we're done defining the source and destination, and now we need to set up the copy from the source to the destination. And I said before, we need to have a graphics object defined on this destination bitmap. It's going to be the same size, and we got to specify some other things about it. And here is where we set up that graphics object. And again, I called it canvas. And basically, I am defining a graphics object from the image of the tile. At that point in the iteration, I and j, the bitmap array element will define this graphics object or this tile called canvas. Okay, so using that graphics object, here is the method inside the graphics class. Here's the method that will allow us to draw from the source, the source image to the destination bitmap using this canvas as a destination. So what I need to define in this draw image method, so draw image draws from this source, and it's called bmap, that's the source, the main image. From this source, it will draw to this graphics object on this array. Okay, it's a little bit confusing, but this draw image, you use this as the source, the bmap, which is our source image, draws it to this canvas on this bitmap array element. Now, I need to define also the rectangle on the destination bitmap that I will draw those pixels to. Remember, I need to define this rectangle. That's what I'm doing here. I can define this rectangle as any size or location, but here we're going to set it at 0, 0, which is the upper left-hand corner of that bitmap array element, and just the tile size width. So it's going to put it right on the destination bitmap at the same size. Okay, so I'm defining the source, the destination rectangle in which I will copy the source pixels, and here is the location on the source, that moving tile frames that we talked about before. Basically, this tile frame. Okay, we're using that. We set that up before, and now we're using it to specify. And the graphics unit, we're basically using pixels. We're copying pixels. Okay, so really we're doing what we said we were going to do. You set a source, a destination, define rectangles for both to show exactly where you're copying from and where you're copying to. And we're using a graphics object because that has a method that allows you to do that very easily. So there we've basically defined our tiles and set them into this 4x2 array. And when we're done, we return BMP array, which is the 4x2 elements, and we're pretty much done. Now we can return that and put those into the picture boxes, and you've got your tiles. Now, the next thing we need to do is take that bitmap array and modify the colors to get rid of the blue. So here I've got the parallel image processing method we talked about. I'm passing in that bitmap array that we just made, and I am modifying the colors to take out all the blue and all the pixels of all of the elements, and then returning that bitmap array with all of them modified. Okay? Now to do that, we're going to use, as I mentioned before, the Parallel.For. And basically what this does, it looks very much like a regular for loop. The syntax is a little bit different, but it behind the scenes will take these iterations and put them on separate threads, and you don't really have to worry about it. So it's a very, very nice way to do this. So normally I would have a regular for going from 0 to 3 and 0 to 2, and it takes each bitmap element and modifies each pixel in the bitmaps. But this Parallel.For will do this on separate threads. Now, the syntax of this is a little bit different. What this says is, do this for loop for x going from 0 to less than 4. Now, this says for, but it means it is an exclusive for. So excluding for, go from 0 to excluding 4, so that'll be 3. So I'm going from 0 to 3, and this means do this in the brackets. Okay, do this, all of this action that's within these brackets. So I'm looping through 3 times what's in these brackets. And inside these brackets, I've got 3 for loops. This for loop just allows me to iterate through the other elements. I'm going from across the top on 4 and up and down on 2 for the 8 elements. And for each element, I'm just defining the width and height of the tile, getting it from each bitmap's width property. And these are all going to be the same for each. And here I'm going through for each element in the array. Each tile, I'm going from the width to the height, and I am doing the get and set pixel exactly the same as we did in the image processing video, where we initially defined the get and set. And I'm just taking the element in the bitmap, getting each pixel, and taking that get pixel gets the RGB and alpha color from that pixel, and I'm assigning that to old pixel. Here I am taking that old pixel red, green, and blue, and I am zeroing out the blue, but taking the red and green, and I'm assigning that to a new color called new pixel. Okay, so I'm just taking the color from the old pixel, zeroing out the blue, and making that new pixel. And in here, I'm just doing a set pixel to overwrite that old pixel color with the new pixel, which has 0 for blue. Okay, exactly the same, but I'm doing it on each element, each tile in the array. So here you've got basically the code to do parallel processing using the Parallel.For to parallel process and multi-thread behind the scenes for you all of the 8 elements to do all of the images in the array. Now, the question is, will that take our 8 CPU cores and will it use each of those cores for us? Well, let's take a look. Let's run this. I'm going to open the image. I'm going to take the image, and I've got the tiles. So let's take a look. Here I'm using the resource monitor, and you can see here is CPU 1, 2, 3, 4, 5, 6, 7, 8 down here. And let's watch. I will go through and I will initiate the parallel processing, and let's see if actually we get a spike in all 8 cores. So I click, it does it. Let's look here. Yep, you see a spike in all of the cores. So presumably this is processing all 8 of these in parallel concurrently on different threads and different cores. So this hopefully gives you an idea about how you can break up your image processing. Now, obviously, if there's something such as lock bits that goes instantaneous, you probably wouldn't want to do this for image processing, but this is a good graphical illustration of how the real world effects of doing these things in parallel, what the results are, and you can see it visually. So that's why I used image processing. So anyway, I hope this helps and gives you a good idea about what you can do with it. Thanks a lot. Have a good day.